Good morning, dear students. Our lesson today is polynomial functions. We knew before that we have three kinds of polynomial functions. The first kind is the constant function. Example is f of x equals c, where c is a real number, such as f of x equals 2. This is a constant function because its degree is 0. How can we draw a constant function? We have something like this on first term. The constant function is represented by a straight line parallel to x-axis. You remember something like this, f of x equals 3. This example is booklet page 6. So please now open your booklet, page 6. How can we draw f of x equals 3? Okay, let's make a table for this. This is x and this is f of x, and we put three numbers in x and find their values on the function. So we have 0, 1, 2. So f of 0 equals 3 because there is no x here to replace 0 in. So we have 3. F of 1 equals 3, yes. F of 2 equals 3. So let's put these numbers on the graph. First number, or the first order pair, is 0 and 3. This is 0 and 3. Okay, 1 and 3. This is 1 and 3. 2 and 3. And this is 2 and 3. So we draw a line now. It's a straight line parallel to x-axis. Okay, and can we draw now f of x equals negative 2? It's a straight line parallel to x-axis and passing through negative 2. So this is the line. Okay, how can we draw f of x equals 0? Yes, it's a straight line parallel to x-axis. Actually, it's the same as x-axis, so this is the line. Okay, the second kind of polynomial functions is the linear function. And the degree of the linear function is first degree. Let's write this here. Degree equals first degree. It means the highest power of x is 1. And we studied something like this in first term. It's f of x equal mx plus c. Do you remember what's this m? Yes, it's the slope. This is the slope. And c, it's the intercept part of y-axis. An example on booklet page 6 represent graphically. Let's write this, booklet page 6. F of x equals 2x minus 4. How can we represent this graphically? Okay, we make a table. Sorry for this. I'm gonna make a table. This is x, this is f of x. We put three numbers of x, 0, 1, 2, and replace and find f of 0, and find f of 1, and find f of 2. These are the three replacements of x. We have here f of 0, so f of 0, it's 2 times 0 minus 4. The answer is negative 4. So the first order pair is 0 and negative 4. Then we replace x by 1. So the answer is negative 2. Second order pair is 1 and negative 2. So we have here 0 and 4. This is 1 and negative 2. And the last one, 2 and 0. Because we replace x by 2 here, so the answer is 0. Let's put these numbers on the graph. And this is the graph because 0 and negative 4, this is 0 and negative 4. 1 and negative 2, and this is 1 and negative 2. And the last one, 2 and 0. This is its place. Okay, we studied constant function and linear function in the first term. In this term, we're going to draw a quadratic function. And you remember the quadratic function, it's the degree of the quadratic function is second degree. Let's write this here. The degree equals second degree. Okay. This is an example for a quadratic function. You see the highest power here is 2. This example is in booklet page 7. Example 2, actually, I'm going to answer it now. Represent graphically f of x equals x power 2 minus 2x plus 1, where x belongs to the closed interval negative 1 and 3. Okay, and we are going to make a table. This is x and this is f of x. And the numbers here that I'm going to put in the table, not 0, 1, 2, I'm going to put the numbers between negative 1 and 3, actually the whole numbers. So we have negative 1, 0, 1, 2, and 3. And we find the answers of these values when we put them or replace these numbers, or replace x by these numbers. To do so, we have f of negative 1, which is negative 1 power 2 minus 2 times negative 1 plus 4. So the first order pair is negative 1 and 4. Okay, the second one, f of, this is the place, you see, this is the place of negative 1 and 4. We have f of 0, it's 0 power 2 minus 2 times 0 plus 1, the answer is 1. So the second order pair is 0 and 1, and this is the place of 0 and 1. This third order pair, which is f of 1 equals 1 power 2 minus 2 times 1 plus 1, and the answer is 0. As you see, every time we replace these numbers in the function, and to get these values, then write the order pair and put the order pair on the graph. We have f of 2, and this is the place, its place. We have f of 3, and the answer is 4, which is 3 and 4, and this is its place. Now we are gonna join these points starting from the first point to the last point as this. Okay. Some questions ask about something about this graph. The first thing the question asked about it is the vertex of this graph. And the vertex means the head of this graph. This is the vertex of the graph. And we write it as an order pair, which is 1 and 0. And you see that the vertex, actually, most of all vertices, and it's the middle number in the table. We have 5 numbers between negative 1 to 3. So the vertex is the middle one. We have here 1 and 4. We have here 1 and 4. This is the vertex, actually. So the vertex is 1 and 0. Okay, the direction of the curve. This curve is upward, opened upward. Some curves, we're going to draw it, it's downward curves. So we write here, it's upward. The minimum point in such graph, we have a minimum point, we don't have a maximum point. Another graph, we're going to draw it, we have a maximum point. So the minimum point, which means the last point down in the graph, which is the vertex, which is 1 and 0. So when we ask about the vertex, it's the same as we ask about the minimum point or the maximum point in some graphs. So we have here, it's 1 and 0. The minimum value is the minimum value of these values. We have here 4, 1, 0, 1, and 4. So the minimum value here, it's 0. And as you see, and the minimum value is the second projection of the vertex. Okay, the equation of the axis of symmetry of the curve. We have to draw now an axis of symmetry of this curve. A straight line cuts this curve into 2 equal parts. This is the axis of symmetry. And if we want to write the equation of axis of symmetry or any straight line parallel to y-axis, it's x equals the number which intersected with the x-axis, which is x equals 1. This is the equation of the axis of symmetry. And you see, this one is the first projection of the vertex. So we can write another rule here, x equals the first projection of vertex. This is the equation of any axis of symmetry. As you see, it's very important to know the vertex in the question, because you know the minimum point from the vertex, you know the minimum value, which is the second projection of the vertex, and you know the axis of symmetry. 5 questions come about this graph. Okay, let's see another example about quadratic function. It's second degree, as we say. Exercise 3. This is booklet, page 8. Represent graphically 4 minus x power 2, and this is the interval. Let's make a table here. X and f of x, and write the numbers between -3 and 3. We have 7 numbers from -3 till 3. Okay, the first number is -3, so we're going to now find f of -3, which is -5. So the first order pair is -3 and -5. Where's the place of -3? Let's put it in the graph. Okay, this is -3 and -5. The second one is f of -2, which is 4 minus -2 power 2 equals 0. So the order pair is -2 and 0. And this is -2 and 0. Okay, the third number is -1, so we find f of -1, which is 3. So the third order pair is -1 and 3. Let's put it on the graph. This is -1 and 3. Okay, we have f of 0, and the order pair is 0 and 4. We have f of 1, which is 1 and 3. We have f of 2, which is 2 and 0. And finally, f of 3, which is -5, and the order pair is 3 and -1. Before joining these points, starting from the first point to the last point, can anyone tell me where is the vertex from all of these? Yes, this is the vertex, the middle number. You see these values is -5, 0, and 3. We have here also -5, 0, and 3. So this is the vertex. And if we draw it, you see the vertex is the head of the curve, and this curve is opened downward. Okay, the question asks about 5 things: the vertex, the direction, maximum point, maximum value, and the equation of axis of symmetry. Okay, the vertex, it's the head, which is 0 and 4. The direction of the curve, it's opened downward. We have here maximum point. In the last question, we have minimum point, because it's in the last question we have an upward curve. Remember, we have upward curve, so we have minimum point, but in this graph it's downward, so we have maximum point, which is, we say before, yes, it's the vertex. The vertex is the maximum point. So it's 0 and 4. The maximum value, remember the rule? It's the second projection of the vertex, or we can find it here. The maximum values from all these values. We have -5, 0, 3, 4, 3, 0, -5. So this is the maximum value, which is 4. And the equation of axis of symmetry, it's x equals the first projection of the vertex. This is the axis of symmetry. This is the axis of symmetry. And its equation is x equals 0. Okay. We have another example in the booklet. I'm going to answer it now, which is example number 1, page 6. Yes, this example. Let's see. F of x equals f of x equals x power 2 minus 5x plus 4, where x belongs to from 0 to 5. Okay, let's make a table for this graph. This is x and this is f of x. Okay, if you have a scientific calculator, you can do this using your scientific calculator. Let me show you something very nice. You can make the table on your calculator without just for checking. I don't say use every time the calculator, but I'm saying just check your answer using a calculator. Let's see this. I'm going to show you something very nice. This is my scientific calculator. I'm gonna use it to make my table on the calculator. So I'm gonna put the numbers between 0 and 5. We have here, let's see again, it's, I'm gonna put the numbers, it's 0, 1, 2, 3, 4, 5. Okay. The first number we have here, 0 to the power of 2, uh, I'm sorry, it's 0 to the power of 2 minus 5, oops, this is minus 5 times 0 times 0, okay, plus 4, and the answer is 4, so I'm going to write here the answer is 4. Okay, I'm going to put 1 and replace x by 1 now. It's 1 power 2 minus 5 times 1 plus 4, so the answer is 0. I can use my calculator, I can do it manually, I can use something nice and make the calculator make the table. I'm gonna say it here. Use your calculator to make this table as following. You press mod on your calculator and choose table, and you find, I'm gonna find f of x equals. I'm gonna write your function, which is x power 2 minus 5x plus 4. This function, you're gonna write it here and press equal. Then the calculator will ask you about this interval. So it asks you about the start, and you have the starting point here in your table, it's 0, and then you press equal. You ask the calculator will ask you about the end. So I'm gonna write, you are gonna write your end point here, which is 5, and then press equals. And finally, the calculator will ask you about the step. You move here one step from 0 to 1, it's one step, from 1 to 2, it's one step, from 2 to 3, it's one step. So you're gonna write 1, then press equal, and the calculator will form the table. Okay, you can use it, but I'm gonna do it manually here. So it's 2 power 2 minus 5 times 2 plus 4. The answer is negative 2. And here 3 power 2 minus 5 times 3 plus 4. 3 power 2, it's 9, plus 4, 13, minus 15, so the answer is negative 2. And put 4, the answer is 0. Put 5, the answer is 4. Okay, I'm going to put the order pairs now. So the first order pair is 0 and 4. Okay, 0 and 4. Let's place it here. 1 and 0. Okay, this is its place. 2 and negative 2 here. 3 and negative 2. 4 and 0. Yes. 5 and 4. And this is its place. Okay, join now the curve. Okay, this is the curve. I'm gonna make something like this, a small head down, and this is the curve. Okay, I did this question because we can't find the vertex easily here in this curve. You see, we have 6 numbers from 0 to 5. Where's the vertex? The vertex is here, because the number here is symmetric about this line, negative 2, 0, and 4, negative 2, 0, and 4. Okay, to find the vertex, the x coordinate of the vertex here, it's 2 and 3, so the middle number between 2 and 3, it's 2 plus 3 over 2, which is 2.5. So this is the first projection of the vertex. To find the second projection of the vertex, I'm going to replace negative 2.5 in the function. So I'm going to write f of 2.5, which is 2.5 to the power of 2 minus 5 open bracket 2.5 plus 4. And the answer is negative 2.25. So the vertex here is 2.5 and negative 2.25. This is the vertex. This curve is opened upward. The minimum point, which is the vertex, we said this before. What else? The minimum value, which is negative 2.25. The equation of axis of symmetry, which I'm going to draw it using a ruler. This is the axis of symmetry. And the equation of axis of symmetry, it's x equals the first projection of the vertex, which is 2.5. This is our lesson about polynomial functions. How can you do a quadratic function? We have a homework here, which is examples. We did 2 and 3, so we have example 4, it's homework, example 5, and example 6. We have 3 examples. You must do it in your booklet. Thank you very much, and bye-bye.